So now I want to see how we can compare the reaction quotients and equilibrium constant. So remember, the equilibrium constant differs from the reaction quotients in that for equilibrium constant uses the concentrations at equilibrium, while a reaction quotients use the concentrations at any given time. So that means for you to work out the equilibrium constant, the concentrations of reactants and products must be equal. But for reaction quotients, remember the concentration of reactants and products keeps on changing with time. So you can find reaction quotients at any given time. Then number two, reaction quotients changes during a reaction, whereas the value of Kc does not change unless the temperature changes. So that means the value of reaction quotients, remember, you are using concentrations of reactants and products at any given time. So because the concentrations changes, it means the value of QC can also change. But for Kc, the value must remain constant. So factors that affect a chemical equilibrium. And before we move to that, let us look at Cutler's principle. How does it state? It states that if a system at equilibrium is disturbed by an external stress, the system adjusts to partially offset the stress as the system attains a new equilibrium position. So if you have any factor of any system at equilibrium being altered, maybe temperature, concentration, and so on, the equilibrium will shift automatically to that direction to offset that stress or that change, or to oppose that change. So the first factor is changes in concentration. How does change in concentration affect the position of equilibrium? So adding a reactant or product, the equilibrium shifts away from the ingress in order to consume part of the added substance. Then removing a reactant or product, the equilibrium shifts towards the decrease to replace part of the removed species. So I've been given an example of a reaction. Hydrogen gas combines with iodine to form hydrogen iodide. So they're asking a question, does the equilibrium shift left or right if part A add hydrogen gas? So remember, in that case, you are introducing a substance, you are adding a reactant or a product. So the equilibrium must shift away from the ingress in order to consume part of the added substance. So if we add hydrogen gas here, it means hydrogen gas must be consumed more by combining with iodine to produce more of hydrogen iodide, because you have increased the concentration of reactants. So reactants must be converted to form much of the products for the equilibrium position to be achieved. So that means the equilibrium will shift from left to right. So that one is very clear. So equilibrium shifts to the right to form more of hydrogen iodide. So what about if you remove iodine? If you remove iodine, so remember this second statement, removing a reactant or product, the equilibrium shifts towards the decrease to replace part of the removed species. So if you remove iodine, it means you are decreasing the concentration of reactants. So that means the products part of the products have to be converted to replace the removed reactant. So the equilibrium will shift from right to left so that we can get much of iodine to achieve the state of equilibrium. So then changes in volume and pressure. So remember, volume and pressure are inversely proportional. If you increase pressure, you decrease volume. If you reduce pressure, you increase volume. And remember, increase in pressure will always favor a site of a reaction with fewer number of molecules. But decrease in pressure will always favor a site of a reaction with higher number of molecules. So if pressure increases, it means volume decreases. The system shifts to the site with a smaller number of gas molecules. If pressure decreases, volume must increase, so the system shifts to the site with a greater number of gas molecules. So I think that one you learned in high school. So if you have this example of a reaction where nitrogen combines with hydrogen to form ammonia gas. So if you take the mole ratios, we have 1 mole of nitrogen gas and 3 moles of hydrogen gas. So when you get the sum of the two, we shall get a total number of 4 moles. Then for products, we have 2 moles. So that means the reactant site has higher number of moles or higher number of gas molecules compared to the product. So now the question comes, does the equilibrium shift left or right if pressure is increased? So increase in pressure will favor a site with fewer number of molecules, which is the product site. So that means the equilibrium shifts to the right, since increase in pressure favors a site with fewer number of molecules. We have 2 molecules this side and 4 molecules on the reactant side. Then changes in temperature. So remember, temperature comes with the heat. If you increase the temperature, you increase the amount of heat in any given reaction. So increase in temperature favors endothermic reactions, while decrease in temperature favors exothermic reactions. So endothermic reactions, delta H is normally greater than 0. That means it requires input of heat, while exothermic reactions, delta H is less than 0, which means it requires low temperatures. So you can see endothermic, you must add heat. Exothermic, you must remove heat. So they are saying that how can you compare the value of Kc and equilibrium position when temperature varies? Kc is larger when the reaction shifts to the right. This occurs if T is increased for an endothermic reaction or T is decreased for an exothermic reaction. Remember, you're talking about forward reaction. Kc is normally larger if T is increased for an endothermic reaction or T is decreased for an exothermic reaction. So remember, this one is the opposite now. Kc will be smaller when the reaction shifts to the left. This occurs if T is decreased for endothermic reaction or T is increased for exothermic reaction. So this one is the opposite of that. So look at this equation now. If the temperature is decreased for a reaction, remember this one is what? An endothermic reaction. This value is positive, endothermic reaction. So the forward reaction is endothermic. And remember the first statement, Kc is larger when the reaction shifts to the right. That's the forward reaction. If T is increased for endothermic reaction. So like in this case, assuming if temperature was increased, then the value of Kc will be larger. But they are now decreasing the value of endothermic reaction. So T is decreased for an endothermic reaction. So that means the Kc value will be smaller because now the equilibrium will now shift from right to left. So the equilibrium position will shift from right to left because the forward reaction is endothermic and yet they are reducing the temperature. So the reverse process will take place. So T is being decreased for exothermic reaction now. T is now the value of T is decreased for endothermic and T is being increased for exothermic reaction. So Kc will be smaller. So the equilibrium shifts to the left since decrease in temperature favors exothermic process and the value of Kc will be smaller. So products are being changed to reactants. Now, what is the effect of a catalyst on the rate of reaction? A catalyst accelerates the rate of reaction by lowering activation energy. But remember, a catalyst has no effect on the position of the equilibrium mixture. So the only thing that a catalyst does is to decrease the amount of time taken for a given system to reach at equilibrium, where we have both forward and back a reverse reaction being at a state of equilibrium. So the catalyst does not affect the equilibrium concentrations of reactants or products in the equilibrium mixture. So thus Kc value does not change. So that means the Kc value will remain the same. It does not change. Catalyst does not affect the value of Kc, but it hastens the process by which an equilibrium is established. So now choosing optimum conditions. So the catalyst principle can be used to select optimum conditions to form a substance, e.g. to form ammonia. So you can predict the conditions. 1. This reaction is exothermic, so it requires input of heat. So high temperature is required in this reaction. So one, we talk about high temperature. It will favor the forward reaction. No, not high temperature, but low temperature. Because this reaction involves production of heat. So it means low temperature will favor the forward reaction. Exothermic reactions occurs best at low temperatures. Then in terms of pressure, if you look at the mole ratio of reactants and products, this side will have 1 plus 3. Those are 4 molecules. This side will have 2 molecules. So high pressure will favor a site with a fewer number of molecules, which is our product. So that means the second optimal condition is increase of pressure or high pressure. Then lastly, we consider the influence of maybe the catalysts. This reaction requires ion catalysts. It will accelerate the rate at which the products are formed. So much of the products will be formed in the presence of the catalysts because it will lower the activation energy required for formation of the products. Then also you can talk about increase in the concentration of nitrogen gas and hydrogen gas. So once we increase the concentration, we shall obtain much of the ammonia gas because much of the reactants will be converted to form more of the products. So that is the end of lecture 7. So thank you for keenly following that particular lecture. So next, let us wait for lecture 8, where we shall look at solubility and solubility a product.